Hey guys, I've got the two 8020Bs disassembled here. If you watched the last video on them, you'll know that this one actually died during function testing on AC volts. And I just figured I'd kind of go through troubleshooting it and see if we can nail down the problem and actually get this meter fixed. Now, it shouldn't have died on 120 volts AC. They're rated for, if I can find the cover back here, they're actually rated much higher than that. 500 volt max to ground, 750 volts AC. So I believe that there was just a weak component in there that finally gave up. But we're gonna see if we can track it down and get it changed out. I have both of them disassembled because I'm gonna use this one just as a comparison, just to let me know what values I should be seeing and what values I'm not seeing on this meter. Now, the first clue to me is that whenever we're doing function testing, I've mentioned it before, I believe, that I use a power supply that shows the current draw. And the first clue it gave me that there was something shorted in there was that the current limiter on the power supply was indicating an overdraw. So that shows me that somewhere in this circuit there's a short between positive and negative on the battery side. We're not so much worried about this input side, but I think later on when we get in a little bit more complicated meters, these are actually very simple meters, we'll see a little bit more of how the batteries and the input signals are actually tied together. But first, we want to find out how bad of a short this is. So I've got the 87 in resistance, and we're just going to ohm this out on the battery terminals. And right now, it's not showing us anything. Okay. We've got 264K there. And right now we're indicating an open. That's odd. Oh. The meter has to be switched on. Okay. So now that we've actually got the meter turned on, we can see that we have 8.2 ohms, which is very, very, very low in comparison with this one. So I think what we'll do is flip it over because it gives us a lot better access to all the traces and things. We're going to follow one lead at a time. I'm going to start with this lead because it's a lot easier to follow. And we're going to try to find where this resistance, or actually lack of resistance, is coming from. We're going to try to find this shorted component. Okay, we've got 0.3 there. 0.3 again. 0.3. Okay, and then we move up and across and to here. 0.3, and then we move way down to here. And then we've got a little via that comes up, and it looks like it sends it around into here. So this is the puppy right here. So let's try you again. Which one was I on? 5.2? I don't... okay. So somewhere in between that is where we're going to be looking. So we actually need to move up higher. So let's get back to the component side of the board, because now we know that we're looking kind of above this area of the meter. And I think we'll go ahead and actually try to trace out the positive, which we know is going to go to the switch. So that actually is going to require us to flip it back over. So let's do a quick little check here. 0.6, 0.6, 2, and that's probably just a little bit of switch resistance in there. That's open, that's just the anchor, but it sends it to there. Hang on. There, in here. Whoa. So this resistance is higher, so I think that's a wrong track there. Tell you what, let's see if we can figure out from this on-off switch what we have. It looks like I have a trace here. It looks like there's a trace coming off the switch and it comes down and feeds this. Let's see. So, if we're going to measure from there, then I ought to just clamp something onto this. Okay, so that's 0.8. It's 0.7. I think we're still picking up a little bit of that switch resistance there. Let's try the other side of this component. Ooh. I think we found it. 7.4. That seems, let's see. Let's try you. This is the matching component for this meter. Wow. As you can see, this is where we're getting most of the resistance from the battery circuit. And this one seems almost directly shorted. What is that? Looks like a 63B. Let's see if we get the same ones. We've got a 1N. I see a diode symbol here. And a diode symbol here. So, it looks like a standard diode. I wonder if they're just using this maybe for input protection, just in case you put the reverse polarity on the battery, which we know that wasn't the case, because we were working and then it was when the AC voltage got introduced. Could they be using that like a fuse? I don't know. But that seems to be the problem there. So let's get that. There's actually a better way to test that, because it is a diode, and testing it in circuit is not the greatest thing in the world. So let's go ahead and warm up the Heiko, and we'll get this thing set up on the PCB device. Again, poor thing. Alright, so we went over desoldering before, in fact on this same meter. So let's introduce a little bit of flux in there. And then we'll just use a little bit of the 032 solder. And we're just going to unclamp one lead for now on this. This is going to be a little tricky. We could actually cut the leads if we were convinced that we had to replace this, but I'm not, so I'm going to go ahead and just desolder a lead. Now, that's taking that completely out of circuit. So let's check this as a diode. We already know that we're getting a lot of resistance out of it, but we want to make sure that since it is a diode, that it's still acting like a diode. It is actually still acting like a diode. So let's go ahead and check the resistance again. .56 mega ohms. We may have just chased the wrong rabbit down the hole. Alright, so I had to do what no man likes to do, and I went to the instructions and read the troubleshooting guide for these meters. The recommended troubleshooting tree, or whatever you want to call it, did actually lead me to the diode that we checked earlier, but as we saw, that wasn't the problem. And next up, it actually shows the chip. And I've already checked the chip, and it is in fact shorted. So I'm just going to kind of run through and show you how I did that. I've got the 87 in continuity mode, so we'll hear some beeps if we have any shorts. What I'm going to do is I'm just going to grab right on the first pin. This is going to be a little bit awkward, but I think we can handle it. And I'm just going to run across here. And then I'm going to move to the next pin, and I'm going to run across. And we'll just continue that. It's one of the good things about the 87 is with that really fast continuity on there, you can just drag right across here, and it's not going to take a whole lot of time to check all these pins. Right now, okay. Look at that, 4.7. Well, that's the problem. Let's go ahead and swap it with another chip and put the meter back together and see if that does it. I think I'll spare y'all all of that though. Alright, so I've got it put back together except for the front cover, and introducing a voltage and comparing it to the 192, and it is dead on. So this chip was definitely bad, and it's a A to D converter, So I may actually try to find another one, because now that I'm looking at this one, this is the one that was, the measurements were all over the place. I'm really wondering if I can't fix it. So, but now it's minus a A to D converter. So I may try to find one of those. If not, we may end up swapping another chip for it and actually trying to tackle that other meter and seeing if we can't actually get it working and have a repair that's a little bit more eventful, a little bit more challenging, just to have some more fun. Well, that'll be it for today, guys. Thanks for watching, and stay tuned for the next one.